So we've kind of established that the change function, or the rate of change function of a quadratic, is linear. Now we can actually go backwards and say that if we have linear changes, we can build a quadratic function. So if we do this, we could start with a change in y. So now I want you to choose your own, okay, but use a linear change function and you can build a quadratic function, and then you can actually work out the function value for this, the actual equation for this. So I'm just going to go, I'm just going to go 1, 2, 3, 4, 5, 6, 7. Okay, I want you to use something different, but I'm going to build my quadratic function this way. Okay, and if the change in y is +1, I'm going to just go 1, +2 is 3, +3 is 6, +4 is 10, +5 is 15, +6 is 21. So we're not going to use that value here. Okay, so there's my changes, and I've built my y value, so we'll just go up by ones here. 2, 3, 4, 5, 6. Now, there is a quadratic equation that can be calculated using those values. Okay. Now, the nice thing about this is it is centered at 0, 0. Okay, so that we know that our quadratic function is going to be y equals x squared plus 0. Okay, and we'll do ax squared like that, and we can actually work out this is ax squared plus bx plus 0. Okay, so we don't know that we don't necessarily know that that's vertex. So we can work out this quadratic function, and we can do this with some plotters as well. But I'm just going to do this one algebraically. Okay, so let's just take some coordinates. So I know that this is my function here. So maybe I'll just highlight that in a different color. Okay, so this is my quadratic function. Now I need to just come up with an equation for this, and there my equation is going to be in general form: y equals ax squared plus bx plus 0, since I know I have that 0 y-intercept. I'm just going to solve for a and b. I'm just going to plug in two coordinates. I'm just going to use, for equation 1, I'm just going to use 1 and 1. So y equals 1 when x equals 1. Okay, so 1 is equal to a plus b. I'll use the next coordinate 2 and 3 as my other coordinate. So when x is 2, y is 3. So x is 2, so it's going to give me 4a plus 2b. Okay, and then why don't we do, I'm going to times equation 1 by, let's get rid of the b. So I'm going to end up with 2 equals 2a plus 2b. And I'm going to solve this system for the a and b values. So I'm going to subtract this. I get 1 is equal to 2a. So a is equal to 1/2. And b would then be equal to 1/2 as well. Okay, I'm going to plug it back into equation 1. So this is my quadratic. The quadratic equation for this particular function is going to be y equals 1/2 x squared plus 1/2 x. Okay, so this is the quadratic equation that goes with this linear change. It's just 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay, so we can build the quadratic equation from the changes. We can start with a linear change, and build a quadratic function in that way. So this app here, this app that you can use, we can actually plot the change function based on the original function. Okay, so this is what we're going to do next. We're going to start with our linear function here. Okay. So this is going to be 2x plus 3. going to be a slope of 2, a y-intercept of 3. It's basically a linear function. And what I want you to do is use that plotter to find the change function. Okay, so what is the slope function for this equation? In fact, this is a linear equation, so it has a constant slope. So you should see that it generates a constant slope. This one here, we know that the quadratic, okay, this is a quadratic function, and we know that the change function, or the rate of change function, is going to be a linear function. And it's gonna, we've done this one already, but I want you to use a plotter to plot these.